The Northern Lights are one of nature's most mesmerizing spectacles. It is everyone's dream to witness this mesmerizing natural phenomenon. But how can you see the Northern Lights in the best way? To see the Northern Lights, you need to be in the right area and at the right time. After watching this video, you will be able to choose the best time. Firstly, we want you to understand the scientific facts behind the Northern Lights. So let's start with this. How are the Northern Lights formed? In addition to being a fascinating spectacle of nature, the Northern Lights are a phenomenon that varies depending on the cycle of the sun's magnetic activity. Coronal mass eruptions and solar storms are constantly occurring on the surface of the sun. These eruptions are very large, sometimes even the size of the Earth. These powerful eruptions and storms on the surface of the sun are scattered around, and some of them travel towards the Earth. But the Earth's magnetosphere protects it from the sun's harmful rays. The solar winds constantly eject these ionized atoms. Earth's magnetosphere blocks most of these charged particles, but some ions can be trapped for short periods of time in the planet's polar regions. In these areas, the ions collide with oxygen and nitrogen atoms in the Earth's atmosphere, creating bright, colorful photons. The Northern Lights are the result of these charged particles interacting with the Earth's magnetosphere. The sun's magnetic activity cycle is about 11 years of activity. This means that the sun's magnetic field changes completely, shifting the north and south poles. The solar cycle affects the activity on the surface of the sun, creating much stronger eruptions and storms once every 11 years. This is called solar maximum. The last solar maximum occurred in June 2014. According to NASA, the next solar maximum is expected to occur in July 2025. The stronger the solar storms, the more particles come to Earth. The result is a wider and longer-lasting spectacle. These lights occur at both poles of the Earth. Scientifically, the lights at the North Pole are called aurora borealis and the lights at the South Pole are called aurora australis. People are generally more familiar with the Northern Lights. This is because human settlements are closer to the great aurora borealis and can be observed more often. How are the striking aurora colors created? The spectacular colors of auroras vary depending on the type of atoms the ions collide with and their altitude in the atmosphere. For example, ions hitting oxygen atoms above 240 kilometers altitude produce reddish photons, while ions hitting oxygen at lower altitudes produce green-yellow photons. When ions collide with nitrogen atoms up to an altitude of 90 kilometers, blue photons are produced. Above 90 kilometers, reddish and pinkish hues are produced. On the other hand, ions hitting hydrogen and helium atoms produce blue and violet photons. However, our eyes perceive this part of the electromagnetic spectrum less clearly. The Earth's atmosphere contains mostly oxygen and nitrogen gases. And the lower you go below 240 kilometers, the more likely collisions are. This is why we usually see auroras in greenish and yellowish colors. So what are the different shapes of auroras? There are multiple factors that make auroras have different shapes. These include the intensity of the sun's magnetic activity, the types of charged particles, the types of pulses in the atmosphere, the height at which they collide, other light sources, and your location. No two auroras are the same. Moreover, an aurora is always in motion and subject to change. In general, though, auroras can be seen in the following ways. Curtain. These shapes are called curtain drapes or drapes because they look droopy and wavy from a distance. They are widely visible. Ray. The rays are columns stretching from bottom to top. We can compare it to a colorful skyscraper suspended in the air. But unlike a skyscraper, the photons that make up these auroras are colorful and moving forms of plasma. The beams are most visible during periods of intense solar magnetic activity. Patch. Patches are flickering, diffuse auroras that appear drop by drop in the sky. Patches are scattered in the atmosphere by a plasma wave. They are rare, visible, and fainter. Arc. Arcs are simple arc-like forms of aurora that can extend thousands of kilometers horizontally and hundreds of kilometers vertically. Arcs can appear along the horizon. They occur when the sun's magnetic activity is low and are the most common form of aurora. Band. Bands are similar to springs but have more curves and an aesthetic appearance. Bows can transform into bands in a few minutes. Some people now recognize bands as a form of bow. Corona. Coronas appear in the form of a crown. They usually have purple, white, and bluish hues. They are more common during periods of intense solar magnetic activity. The history and the scientific discovery of auroras. The scientific understanding of auroras has been shaped by a long and intriguing history of discovery. The earliest known record of auroras is thought to be Stone Age cave paintings dating back 30,000 years. Some primitive drawings found in Cro-Magnon-era caves in southern France are believed to refer to the Northern Lights. The phenomenon has been referred to throughout history, including in Aristotle's Meteorology, written 2,000 years ago. The scientific discovery of auroras began in 1621 when French scientist Pierre Gassendi first observed them. A century later, the English scientist Edmund Halley proposed the first scientific finding that was accepted and validated in his time. In 1716, Halley explained the aurora as follows. The aurora rays are caused by particles affected by the magnetic field. The rays are parallel to the Earth's magnetic field, and the shape of the vault is due to the phenomenon of perspective. In 1778, Benjamin Franklin hypothesized that auroras are caused by the concentration of electric charge in the air in the polar regions, which is intensified by snow and moisture. In 1908, Norwegian physicist Christian Birkeland developed a theory to explain the relationship between auroras and magnetic fields, suggesting that they interact in the polar regions to create colored lights. Christian Birkeland was the first to test that auroras could be related to particles from the sun. To confirm this hypothesis, he conducted an experiment called TRELLO with a magnetized ball, which represented the Earth being bombarded by charged particles from the sun. Today, space exploration is being conducted to learn more about the formation and properties of auroras. The ongoing efforts of scientists, combined with technological advances, ensure that this fascinating phenomenon continues to evolve. In addition to science, auroras have also been an influential phenomenon in culture and art. For example, Frederick Edwin Church's famous painting Aurora Borealis captures the northern lights quite well. The painter depicted the aurora on the battlefield on the night after the Battle of Fredericksburg in the American Civil War. Because the northern lights were seen so far south, the Confederate Army interpreted it as a sign that God was on their side. Auroras have fascinated people throughout history. In particular, the northern lights have played a major role in the history of the peoples living in the Arctic region. The cultural and mythological history of auroras is a topic of another video. So, where can you see the northern lights best? According to the Tromsø Geophysical Observatory in Norway, the northern lights are usually best seen in an area about 2,500 kilometers in radius from the North Pole, called the Aurora Zone. If you think of this area on a 2D map, it looks like this. To see the auroras, you need to be in countries that are in or near this area. So you need to be at least in the Scandinavian countries, Finland, Greenland, Canada, the Faroe Islands, Siberia, and Alaska, but being in these countries is not enough. Because the northern lights are not visible at every moment and in every region. You need to choose the right place and the right time to see the northern lights. Since the northern lights occur in the polar circle, the further north you are, the better. If you are planning to see the northern lights, we can recommend going to one of the following regions that might be suitable for you: Tromsø in Norway, Fairbanks in Alaska, Yellowknife in Canada, Abisko National Park in Sweden, Rovaniemi in Finland, Northern Siberia in Russia, Greenland, the Faroe Islands, and many destinations in Iceland. You can also witness them in northern Scotland if you're lucky. These are some of the best places to observe the northern lights. However, when the sun's magnetic activity intensifies, it is possible to see the northern lights over a much wider area. Therefore, if you are planning to see the northern lights, you can choose one of these regions or somewhere close to it. But whichever region you choose, if you want to see the northern lights well, the place you choose should be away from city lights. Because city lights make it difficult to see the auroras. So what is the best time of year to see the northern lights? Just as natural and artificial light on Earth makes it difficult to see the stars, it also makes it difficult to see auroras. The best time to see the northern lights is during long, dark nights. That is, from September to March. On the other hand, the best months between these dates are December, January, and February. Since these are the darkest and longest nights, the chances of seeing the northern lights are quite high. The peak times outside the winter months are close to the equinox on September 23rd and March 21st. This is because on these dates, day and night are equalized and more solar particles interact with the atmosphere in the Earth's magnetic field. On the other hand, in winter it may be difficult to see auroras despite a few hours of dim daylight. So you should always try to prefer dark nights. According to the Geophysical Institute at the University of Alaska Fairbanks, auroras are most prominent between 21:00 and 3:00 at night. On the other hand, experts at Northumbria University say that the brightest northern lights are usually between 2300 hours and 12 o'clock local time. In fact, in some destinations in the Arctic, there are hotels that wake up guests during the auroras. But keep in mind that this is just a general overview. The Arctic is a very large area. The intensity of light is different in each country in different months. It is also difficult to predict the magnetic activity of the sun. Before going to the Northern Lights, we recommend you to do a good research to find the best place and the best time. The Arctic has harsh weather conditions. Therefore, you should research the region you choose in more detail according to the local weather and geographical features. Because you don't want your plans, travels, and expenses to go to waste. So, are auroras dangerous? There is no evidence that auroras directly affect human health. The sun's charged particles, the source of auroras, are very powerful cosmic rays. But most of them are deflected by the Earth's magnetic field. Auroras are not completely harmless, but they do not pose as great a danger as is often exaggerated. Very strong magnetic activity can cause some communication problems due to radiation. At most, you will be without internet and electricity. It is also not a permanent and life-threatening event. There have never been auroras strong enough to destroy life on Earth. Even the 1859 solar storm that caused the Carrington event caused many frightening technical problems but killed no one. We are unlikely to experience such an event anytime soon. Let's face it, if it weren't for the exaggerations in some documentaries and the negative influence of social media, most people wouldn't even know about cosmic rays. However, it is important to be prepared and aware of the dangers. In winter, weather conditions in the Arctic become even more extreme. You can get out of your comfort zone, especially when you get away from the cities. However, it is difficult to find the same conditions in every region. So it is not possible to have the same experience in every region. Still, we want everyone who watches this video to have the safest and most enjoyable experience possible. So, what can you do to protect yourself and have a good experience? Here are some good tips. First of all, to go to the Northern Lights, we recommend that you choose places where there are human settlements and easy transportation, because you may need to find solutions to communication problems due to radiation and heavy snow. If you are a tourist or don't know the area well enough, it is a good idea to have a local map and compass with you. A map and compass are good tools just in case. You can find out if there are other human settlements, shopping stores, hotels, restaurants, etc. in the area you are visiting. The Northern Lights are usually seen during the cold winter months. It is important to dress warmly and have protective clothing against the cold weather. The brightness of the Northern Lights can have a negative effect on the eyes. Also, the rays reflected from the snow can damage the eyes. It is therefore a good idea to wear snow goggles and other protective glasses. Finally, it is also a good precaution to tell someone close to you where you are going before embarking on a distant journey. These are our recommendations. Try to keep them in mind to have a nice and safe experience. But don't be intimidated by them. Most of them are things you will do anyway. We are just reminding you. You can check the resource links in the video description to do your own research. We have left some good links that we think are useful for you. Some websites provide regular information about the weather in auroras. They can help you determine your own time. You can also write your ideas, questions, and criticisms about the general topic in the comments section. Don't forget to like and subscribe to our channel if you found the video useful. See you in the next video.